Now let's talk about quadratic applications. We have several different types of quadratic applications, but we'll only focus on the first type in this section. The second type of quadratic applications will come when we talk about quadratic functions and equations in a following chapter. Quadratic functions can be used to model many different natural phenomena, including projectile motion, meaning we're throwing objects, throwing a rock, or throwing a baseball. The natural path of those objects are in the shape of a parabola. We can also have situations where we're using a quadratic function to model cost, revenue, or profit in a business. But often in these situations, we want to know when a maximum or a minimum value occurs. And when, remember from the previous lesson, when is an x value. What x value gives us a maximum or a minimum? And the maximum or minimum will depend on our situation, and it will depend on our quadratic function. It's a maximum if a is negative. It's a minimum if a is positive. An important piece to know, x value tells you when the maximum occurs. The y value tells you what the maximum is. And this is for a vertex, the vertex x value and the vertex y value. Let's take a look at our first example. A baseball is hit into the air and its height in feet after t seconds can be calculated by this function right here. H of t equals negative 16t squared plus 64t plus 2. The numbers that are in this function have specific meanings, physical meanings, things that act on a baseball or things that are important when we throw a baseball is how high the baseball is once we start. So the moment the baseball is hit, how high is it above the ground? How fast did it start traveling once it got hit? And then also, how does gravity affect it? So in the physical situation of the baseball, we have gravity, we have its initial speed, and we have its initial height. And all three of those numbers are in this problem. And we'll talk about it in just a minute. I want to talk about part B before I explain those numbers. So first problem, part A, what is the height of the baseball when it is hit? The moment that it is hit, or to rephrase it, to get us started, at the moment it is hit, how much time has passed? Well, the very moment that it is hit is when the clock starts on this function. So our time is 0 in determining how much time has passed the moment that it is hit. The moment that it is hit, time is 0. We're going to plug in 0 for t. So I plug in 0 into my function. Negative 16 times 0 squared is 0. 64 times 0 is 0. And I'm left with 2. 2 what? 2 feet above the ground. So you can think about, we have a baseball coming in, and we have our batter, and he's going to hit that ball. Our batter hits that ball and makes it change direction. But the moment that ball is hit, it's 2 feet off the ground. So going back and talking about what's going on in the function, h of t equals negative 16t squared plus 64t plus 2. Oh, hey, look at that. That's not a coincidence. This constant at the end is the initial height of whatever it is that we're throwing or hitting or lobbing or dropping. Initial height. This value right here in the middle with the t, this is the initial speed of whatever it is we're throwing, hitting, dropping, etc. And this negative 16 part is gravity. So you'll see negative 16 a lot if we're doing feet and seconds. Negative 16 will show up again and again in these functions. You'll need a little bit more physics and a tiny bit more calculus to understand why it's negative 16, because acceleration due to gravity is 32 feet per second squared. This is not something that you need to memorize. I'm just trying to pull in some context into the whole scenario. Here's a function, and I want you to use it. I want you to know that there's some meaning behind that function, okay? So, yeah, a tiny little bit of calculus, and then you'll understand why the gravity number is 16 in our functions. Determining the maximum height of the baseball, maximum height means to find the vertex. So in our previous lesson, we had a quick formula that we could use to find the vertex. X equals negative b over 2a. We're going to use that same formula here. Negative b is 64 over 2 times a, which is negative 16. In these real world examples, it is very unlikely that your x would be negative. I'm trying to think of an instance where x would be negative, and I just can't. Because we're talking about real world things, x usually represents a quantity of something. We're making something, we're making widgets. Or x represents time, and in this case it does represent time, so I'm going to change my x to a t so that I can be consistent with my function in t. It's just a letter change. And then I can divide these out. Negative 64 divided by negative 32 turns out to be 2. Time is in seconds, so this is not answering my question. It says determine the maximum height of the baseball. 2 seconds is not a height. So what do I do with that? I plug it back in. H of 2. Negative 16 t squared plus 64 t plus 2. Plug in 2. Simplify it. 4 times negative 16. And we get 66 feet for the maximum height of the ball. I'll leave you to try number 2 on your own. It's a similar function. Notice negative 16 is showing up again. What is the height of the stone when it was thrown? You may be able to read it directly from the function itself, but make sure that you get that solid understanding of why the answer is what it is. And then the same idea, find the vertex, find the maximum height of the stone that occurs. And there's more. Maximum or minimum, how many seconds? This one's pretty long, but it's the same idea as before. And there's a little bonus question for you. Did the person throw the stone upward or downward? And you have to figure out how you know it's upward or downward. Did he throw the stone up off the cliff and then it fell down? Or did he throw the stone downward from the cliff and it went fast going down? And so hopefully you'll gather that from the information that's given and the information that you find in the problem.